consistently, and they use X, Y, and Z features, then you're going to hit those features really hard, and maybe leave the 1% of the people who use this, mail merge or whatever in the dust. So, which tests? Do you know anyone who uses mail merge? I don't know anyone who uses mail merge. All right. So another question to ask is, which tests achieve large amounts of code coverage as quickly as possible? One thing I should mention is that it is not possible, or it is not feasible, to reach 100% code coverage. Again, it's the law of diminishing returns. If you've got 100 tests, you run 50 of those, maybe they'll cover 90% of your code. You can run another 50 and cover 98% of your code. There have been a lot of research studies done that show that 100% code coverage is not feasible. It takes a very long time to reach 100% coverage. Just want to throw that out there. So some solutions for this are to run only tests that exercise the changed code and code that depends on code that changed. So if you've got regression tests and you fixed a bug or you added a feature, you know which pieces of code changed and which pieces of code didn't. And you can use control flow or data flow profiles from your tests running to know which tests are going to exercise these pieces of changed code, which code depends on that code that changed, and which tests to run first or only to figure out if you've got any new bugs in your software. You can use dependence graphs to do this. So maybe you've got your handy UML graph of your software, you know that this function has a little arrow to that function, you've got a little cloud over here that says this data is going there. But as you develop software, your software can change. Duh. Your UML diagram may not change with your software. It may not keep up. You may have unexpected information flows or data flows from one class to another that your UML diagram doesn't cover. And so that's why dependence graphs or UML diagrams are less precise for this purpose. They're pretty good. If you don't have time to, construct a data flow profile, UML is better than nothing. But profiling is ideal for this. Another way to select or prioritize your tests is to concentrate on code that has a history of being buggy. So if you know from your function call profiles that you've collected from the field or from tests or from wherever that functions X, Y, and Z always have bugs in them, and they keep getting them, and they're fragile and they break a lot, then you're going to run tests that exercise those. So this third point probably looks a little mysterious. Run only one test per bug. How do you know which tests are finding which bugs? You don't have a crystal ball. You don't know which test is going to find a bug. How do you know which tests are going to elicit bug number 342 when bug 342 hasn't been found yet? Well, the answer is that this is a regression test suite, and you have regression bugs. And you know that these may come back. You fix a bug, 3 weeks later, you've got it back. And so when you know which tests elicit which bugs, historically, you can know which ones are going to cover which bugs in the future. So let's pretend I've got my clusters here. Let's say I've got a cluster of these 5 tests here, and I've got these here. So these are execution profiles of tests on the software, and I've clustered them. Let's say that this is one bug, and this is bug 2. If I want to prioritize my regression test suite, I can say, I'll just run one of these, and run one of these, instead of running all of them. Maybe on the next test cycle, I'll pick a different one from each cluster, just for the sake of variety, or for the sake of not running the same tests over again, or finding new things. Some more ways to do this are to run the tests that cover the most code first. I talked about that before. So, also, you can run the tests that haven't been run in a while first. again, we're talking about regression testing. So if you've got a regression test suite that's being run every week, maybe you ran, a subset of these tests this week. You've got a bunch of them that weren't run since August. You're going to run those now. Maybe you'll find some bugs that have been in the software since September. Another way to do this is to run the tests that exercise the most frequently called functions first. If I know from my execution profiles that I've got my monster truck start engine function and it's called 9,000 times per execution, you're going to get a lot of benefits from running tests that exercise this thing first. Because when you find a bug in this function that's being used over and over and over again early, you can fix it early at a lower cost, and the bugs aren't going to propagate through the system. So you're not going to have a bunch of software failures from this one bug. Profiling and operational testing can collect data, and you can use that data to figure out which tests that these are going to be, which tests are going to be the most important for you to run this week. And there are a lot of automated techniques to do that. You don't have to sit down with your profile data and, go through it with a pencil and say, well, okay, let's look at that test. You can write a tool that takes profile data from your program, or from your program while it's being tested. It sifts through that and says, these are the tests that are going to be the most effective according to these criteria, and it spits those out, and I'll say, alright, let's run those. Any questions so far? Everybody with me? Alright. We're almost done. Another issue in test selection and prioritization is granularity. So, what I mean by granularity is, if my test suite is fine-grained, it's made up of smaller tests that test things that are a little bit more specific. Excuse me, I'm going to open my bottle of water for a second. For those of you who don't know, I'm sick today. Trying to fall over. Alright, so fine-grained tests are easier to prioritize because you have more of them. So you have more little tests to look at, you have a larger subset of things to sift through and take a look at and order. Does that make sense to everybody? Okay. So fine-grained tests may pinpoint failures better. So you've got this test that's testing one little thing, it's very specific, it's like 3 lines of code. You know exactly where that's going to fail when it fails, because you're testing something extremely specific, and all these tiny fine-grained tests are orthogonal, they all test something completely different. But fine-grained test suites can cost more and take more time, because, as I said, they can be harder to write. If you've got one big test that is, it's kind of like throw stuff at the wall and see if it sticks, as opposed to something that is crafted to poke at your software in a very specific way, it's going to be more difficult to write something that is more specific like that, and it may not generalize as well, and it may cost more time to run all of these tests. Okay, for the last topic in my talk, I'm going to go to domain-specific techniques, and these are some things that I've seen at software testing conferences. I've seen a lot of papers that have to do with topics in software testing research, but applied to this stuff. So maybe I'll see a bunch of papers on profiling, then I'll see a bunch of papers on profiling with components. So one of the big buzzwords is components. You've got things like Genie, you've got things like NetBeans, you've got things like .NET that you can take components and use them over and over again. And so I would watch for that. I know that components are already a big buzzword in industry, but they're huge in software testing research right now, so I figured I should mention them. There are also domain-specific languages. So if I have something like, let's use the healthcare industry as an example again. If I have some healthcare software that I want to write, and I have a programmer who kind of knows what they're doing, maybe what I'll do is I'll craft a domain-specific language for a piece of software that I have to have them do things to make a plugin or an extension to this piece of software. So let's say that I have an accounting program for some healthcare software, for some people in the healthcare industry. And, sorry, let me start over. I've got an accounting program. I know that some people in the healthcare industry are going to use it. So I'm going to craft a domain-specific language that has functions like bill patient, it has functions like tabulate, it has functions like send to insurance company, things like that. So that people who aren't master programmers can write this stuff. This software will generate code for them and do what they want. And so that's a pretty big thing in software testing right now.